everyone. Welcome to Robert Morris University Math 0900. This is Brianne Pernick, and we are going to start Chapter 7, Lesson 3. In this lesson, we are going to focus on finding the slope of a line given 2 points that lie on the line, finding the slope and y-intercept of a line given its equation, writing the equation of a line given the slope and the y-intercept, graphing a line using the slope and the y-intercept, and lastly, finding the slopes of parallel and perpendicular lines. You do need to know the 3 main vocabulary words for this lesson of slope, parallel lines, and perpendicular lines. So our first topic is finding the slope of a line given 2 points that lie on the line. Now, slope is a word that's used to describe the steepness of an incline or a hill or maybe even a roof. That's probably how you are most familiar with that term. In our case, for the purposes of algebra, it's used to describe the steepness of a line. It's going to describe how quickly your line is rising or how quickly your line is falling. Slope refers to the change in vertical distance, which we refer to as the rise, compared to the horizontal distance, which we refer to as the run, as you move from one point to another on a line. So the graphic that we have here shows what I'm talking about. We have our 2 points, which we call x1 and y1, and x2 and y2. And we can see the change in y, which is its rise, as you move from one point to another. And that's, as I mentioned, called the rise. And then you can see the horizontal change, which we refer to as the run. So we can just look at the pictures of the roofs that we have here. When the rise is bigger than the run, we say that the slope is very steep. So you can picture this by thinking about a rooftop that's very, very steep. That particular rooftop has a rise of 3, whereas the other roof on the right-hand side does not have a very steep roof because its rise, its vertical change, was only 1. When the rise is smaller than the run, the slope is very gentle. It's not very steep. Slope can be calculated by dividing the change in y by the change in x. And we have a formula right here to help us find slope. So we say the change in y, which is often referred to as delta y, divided by the change in x, which is referred to as delta x. So when we want to find the slope of the line using the rise and the run, what you're going to look for is how much the change was. And sometimes it helps to use the little dotted lines, but basically what you're going to look for as you are moving from left to right on your chart, how much did you rise, so to speak, to get from your first point to your second point? Well, we had to rise 1, 2 points. So our rise was 2. How much did we have to run over from left to right? How much did we move over? We moved over 1, 2, 3, 4 units. So my run was 4. And then we always simplify that down because slope is represented as a fraction. So 2/4 can be simplified, and that becomes 1/2. So the slope of this line is a slope of 1/2. That means that it rises 1 unit for every 2 units that it moves over. We can check that. If we move up 1 and move over 2, we should have found another point on that line. We can continue to repeat that. If we move up 1 and over 2, we should find another point on that line. Okay, so the definition of the slope of a line, again, just to review, the slope of any non-vertical straight line that contains the points that have coordinates x1, y1, and x2, y2 is defined by the difference ratio shown here. This is the official formula to calculate slope. And it is exactly the same as what we just talked about up here. It's just shown in a different form. When we're finding the change in something, we're technically subtracting. So in order to find the slope when you're given 2 points, you're going to subtract your y values and subtract your x values. Now, as you're going to notice, that slope formula says that we're going to put y2 minus y1 over x2 minus x1. What's important here is not so much that we particularly start with x2 or we start with y2, but that when you choose a point to be x2 and a point to be x1, we'll say it that way, you have to make sure that you plug into your slope formula appropriately, because if you look back at that formula, your y coordinate for the second ordered pair comes first. The y coordinate for the first ordered pair comes second. The x coordinate for the second ordered pair comes first, and the x coordinate for the first ordered pair comes second. Now, as I mentioned, it's not as important to say which one's first, which one's second, as it is to make sure that you're drawing from the correct ordered pair. Okay, I'll explain what I mean. So I'm just simply going to rewrite my formula because that's good practice to make sure that we have the formula in front of us. Now, what I always do is I simply select one of my ordered pairs to be ordered pair 1 and one of my ordered pairs to be ordered pair 2. It makes absolutely no difference which one is ordered pair 1 and which one is ordered pair 2. It makes no difference in the world which one you pick. What matters is that once you identify one of them as being 1 and 2, you have to make sure that x2 and y2 are put in the appropriate place and x1 and y1 are put in the appropriate place. That is what matters when you're plugging in this formula. So since I identified 2, 0 as my first ordered pair and 4, 2 as my second ordered pair, that means that y2 is 2 and x2 is 4. For my purposes, I prefer to plug in x2 and y2 first, and then I put in my minus signs from the formula next. That way I don't forget about them. And then I'm going to plug in the x and y coordinate from ordered pair 1. So x is 2 and y is 0. I have now successfully filled in the formula, and I'm ready to simplify down by doing the math. 2 minus 0 is 2. 4 minus 2 is 2. 2 over 2 is a fraction that reduces to 1. That means the slope of the line that passes through those points is positive 1. If you think of that as a fraction, 1 can be written as a fraction of 1 over 1. That would mean that your line would rise 1 and run 1, and rise 1 and run 1, and rise 1 and run 1. So your line would look like that as it's falling or being graphed on the coordinate line. But you don't have to do that for this problem. I'm just giving you some insight as to what it would look like. Okay, example 2. We're finding the slope of a line that passes through negative 3, 2, and 2, negative 4. Again, we just are going to label one of the points as 1 and one of the points as 2. It makes no difference which one we label as which. What's important is that once you label them, you keep them in the appropriate position of x1 and x2. That is what's important. So we're now going to go ahead and start plugging in to the formula. So we have m equals y2 minus y1 over x2 minus x1. We are now going to pull from ordered pair 2 in order to plug in x2 and y2. So the x coordinate was 2, the y coordinate was negative 4. I then put in my 2 minus signs from the formula so that I don't forget about them, and then I plug in the x and y from ordered pair 1. So my x is negative 3. Notice how I put the parentheses in there to show separation from my double negatives. And my y value is 2. We're now ready to go ahead and take care of the math. Negative 4 minus 2 is negative 6. A double negative is really like a plus, so 2 plus 3, is 5. So that means that the slope of this line is negative 6/5. So what happens for this line, that means that the rise is going to drop 6 and run 5, and drop 6 and run 5. So your line is going to fall from left to right. That's what that would look like. Again, you didn't have to do this part. You just had to identify the slope. I just wanted to give you an idea of what that's going to look like. What I would like for you to do now is go ahead and do examples A and B. Please pause the recording, and as soon as you are ready to check your work with me, please go ahead and press play, and we will go over the answers together. Okay, at this point you should be ready to check the work for examples A and B. So good practice is to go ahead and write down that formula so that you have it there in front of you. And we are going to label one of the points as point 1 and one of the points as point 2 just to help us plug in. It makes no difference which one is point 1 and which one is point 2. You may have picked backwards from how I did. If you did, that's okay. Just go ahead and follow along. So as we're plugging into this equation, we should have had a 2 over a 5 minus 2 over 0. So now when we do the math, we have 2 minus 2, and we have 5 minus 0, which gives us 5. 0 divided by 5 is always 0, so that means that this slope this line would have had a slope of 0. That means that we are dealing with a horizontal line, because a horizontal line has no rise to it. It does not rise, it does not fall. Example B. We could have plugged in, let's just do 1 and 2. And we'll just reference the exact same formula that I already wrote on the left. So we're going to plug in -4 and -4, minus, minus, 0, and -4. So we end up with -4 over, double negative becomes a plus, -4 plus 4 makes 0. Uh-oh, we are not allowed to divide by 0. Now some of you may have gotten to this point and got your answer. Some of you may have recognized that we're not allowed to divide by 0 and thought that you did something wrong. Others may have just stopped here to see what we do next. When you get this answer where you have -4 over 0, that means that your slope is undefined. That is your answer. The reason that it's undefined is because we cannot divide by 0. What that technically means is that we have a vertical line. That means that we have a vertical line. Okay, so just to review, there are 4 types of slopes that you can achieve. You have the positive slope, which is going to increase as you move from left to right. So the y values will increase as you move from left to right there, okay? And that's the positive. So in other words, your line is going to slant upwards. We have the negative slope. The y values here are going to decrease as you go from left to right. You're going to end up with have a negative slope. Whenever you calculate your slope formula, you will get a negative answer. Your line is going to slant downwards. The next type of line that we can have is the slope of 0. We did that example. We had m equals 0, and I told you that that is the horizontal line. That is a y equals line. I shouldn't have put a number. I should have just put the number symbol. So we'll fix that there. So that's when we have y equals a number. Y equals some number. When you have the m equals a number over 0 as your answer, that is the undefined slope. We also say that it has no slope. That is the vertical line. Those are associated with equations such as x equals a number, okay? So that's what each of the slopes are going to look like. And this little chart here just reviews those 4 types of slopes and gives you a little bit of information to study from. Now, part 2 is finding the slope and y-intercept of a line given its equation. So we're now going to move on to our next objective. Finding the slope and what's called the y-intercept is extremely useful to us when we want to graph a line. When an equation crosses the y-axis, I need you guys to recall from the last lesson that the x value is going to be 0. This point is special, and that's because it's the y-intercept. And if you remember there, it had an ordered pair that we called 0, b. We can use that point to help us graph equations. We have an entire special form of a linear equation called slope-intercept form that incorporates the slope and the y-intercept into it to help us graph equations. That's how important the y-intercept is to us. Now, the slope-intercept form of a linear equation is y equals mx plus b. You need to memorize that equation and never forget it. The m refers to the slope of the line. Okay, m is the universal algebra variable for slope. B is the y-intercept. So when you see mx plus b, that's what those are always going to represent. M is slope, B is the y-intercept. That's always. Now, as you look at this little graphic here, you should be able to see that when it crosses the y-axis, we can see what that intercept is because we can read the y-axis and get the value of b. And then we can find slope by using rise and run, right? We can rise and run to get the slope of that line, and then that gives us our m and b. Okay, there are some other ways to do it as well, but the first thing that you can do there to graph an equation using slope-intercept form, the first thing that you would always do is graph the number that's in the position of b. And then we're going to use the rise and run to move to the next point, plot it, and draw our line. So 2 ways that we can do that there. So just to recap here, the slope-intercept form of an equation is the line that has slope of m, y-intercept of ordered pair 0b, and that gives us the equation y equals mx plus b. So let's take a look at example 4. It says, what is the slope and y-intercept of the line 5x plus 3y equals 2? Well, when you have this type of equation and it's only asking you to find the slope and the y-intercept, your first thought should be, oh, they only need to know those 2 things. I should work to get my equation into y equals mx plus b form, slope-intercept form. That means that our goal is going to be to solve our equation for y. So the first thing that we want to do is subtract 5x from both sides. So we have 3y equals negative 5x plus 2. Then we're going to divide both sides by 3. So we have y equals negative 5/3 x plus 2/3. Y is now isolated, and we can see that the slope, which is the number in front of x, is negative 5/3, and the y-intercept, which is the constant at the end of the equation, is 2/3. Why don't you go ahead and do student practice 4. Please pause the recording, complete the example, and as soon as you're ready, please press play and we will check your answer together. Okay, at this point you should be ready to identify the slope and the y-intercept. So the first thing that you should have done is subtract 4x from both sides. That leaves us with negative 2y equals negative 4x minus 5. Then we want to divide both sides by negative 2. So y equals negative 4 divided by negative 2 gives us a positive 2x. Negative 5 divided by negative 2 gives us a positive 5 halves. Now that the equation is solved for y, we can see that the slope is positive 2 and the y-intercept is positive 5 halves. For graphing purposes, you may want to think of that as a 2.5 later on down the line. Our next topic is being able to write the equation of a line given the slope and the y-intercept. So we were told that the that we want to find the equation of a line that has a slope of 2/5 and a y-intercept of 0, -3. So part A says put the equation into slope-intercept form, which is mx plus b form. Well, m is slope. They told us that the slope is 2/5, so we're going to plug that in. So we have 2/5 x plus b. b is -3. Remember, the intercept is always 0, comma, b. So if you are given an ordered pair that's in the form of 0, comma, some number, then you have your intercept. Since our intercept is negative, we're going to write -3. We're not going to write plus a number. We're writing -3 since the intercept is negative. We now have the equation of our line in slope-intercept form. Now, part B says that we need to write the equation in the form ax plus by equals c. That is standard form of the equation. And standard form of the equation requires that we start with the x term and move it. One second, trying to erase what I wrote there. Standard form requires that we move the x and y term all onto the right side and that we have just the constant remaining on the right. So we want the x and y on the left and just the constant on the right. But we also are not permitted to have fractions or decimals within our equation. So we'll have to deal with that as well. So the first thing we need to do is move the 2/5 x to the other side. So we'll start by doing that by subtracting 2/5 x from both sides. So we have -2/5 x plus y equals -3. My leading term should be positive, and my leading term should not be a fraction. So what we're going to do is multiply our entire equation by -5. That is going to turn the leading term positive, and it's going to eliminate the fraction as we distribute through that equation. So we're going to be left with positive 2x -5y equals 15. And we now have standard form of that same equation. They are equivalent forms. They mean exactly the same thing. They're just used for different purposes. The next section requires us to graph a line when we're given the slope and the intercept. As you can see, they told us the slope right here, and they gave us the y-intercept right there because it's in the position of 0, comma, a number. So you always start with your intercept. You're going to plot that point. So we're going to go down to 0, -3. And then we're going to use the rise and the run. So remember, the slope is 2/3. So the rise is 2, the run is 3. So we rise up 2 and run 3. So there's 1, 2, 3. This is our new point right there. You can always rise and run a second time to make sure. So we rise up 2, run 3. And when you get 3 points that fall on the same line, you graph them, put your arrows on, and you now have your graphed equation. Example 7, we will do exactly the same way. We were given our slope and we were given our intercept. Remember, it's in slope-intercept form already. So when it's in slope-intercept form, we just have to identify the slope, which was -1/2, and the intercept, which is 4. So we start with the y-intercept by putting the point on 4, and we use the slope, which is negative 1/2. When it's negative, we fall down 1 and run 2. Fall down 1 and run 2. That gives us the line that slants down. Your textbook on page 425 has a really great graphic organizer that reviews the 3 ways to graph equations that we've covered so far. The graphic organizer was too big for me to copy and paste and include in the study guide, so I wanted to just point out to you that it's in there. Okay, topic 5. We are going to find the slopes of parallel and perpendicular lines. Parallel lines are straight lines that are never going to touch each other. Because they are parallel and because they will never touch, that means that they're sloping or falling or rising at exactly the same rate. This means that they have the same slope. Think about that logically. If they're rising at the same rate, they're never going to touch each other. Their slope is identical. If they're falling at the same rate, they're never going to touch each other. Their slope is identical. The only thing that's going to be different about them is their y-intercepts. They are going to cross the y-axis in different places. So their slope-intercept forms are going to look the same with the exception of the y-intercept. So just to recap here, there are parallel lines that never touch. They're 2 straight lines that are never going to touch. They have the same slope but different y-intercepts. Now, perpendicular lines, they are 2 lines that meet at 90-degree angles. When lines are perpendicular to each other, their slopes will be opposite reciprocals of each other. If you look at the graph below, the slope of line C is -3. The slope of line D is -1/3. Notice that they're opposite reciprocals. Some other examples of opposite reciprocals, the slope of line D, should be +1/3. Okay, so examples of other opposite reciprocals, if one of the slopes was 2/5, the opposite reciprocal would be -5/2. So one will be positive, one will be negative, and then we flip the fraction. If one of the slopes was 7, the other one would be -1/7. If one of the slopes was -2/3, the opposite reciprocal would be +3/2. That's what we have going on there with perpendicular lines. We take the opposite and we flip the fraction. So perpendicular lines are 2 lines that meet at a 90-degree angle. The perpendicular lines have slopes whose product is -1, and their slopes are opposite reciprocals. If you look at all of the examples that I gave you, if you were to multiply each and every single one of them, they would multiply to -1. I personally think it's easier to look for the opposite reciprocal. So, example 8, part A. If line F is parallel to line H, what would its slope be? Remember, parallel lines have the same slope. So if line F is parallel, its slope would be -2/3. Part B, if line G is perpendicular, what would its slope be? B. If it's perpendicular, you take the opposite reciprocal. So we want positive 3 halves. Example 9. Go ahead and complete example 9 for me. Please pause the recording, complete A and B, and as soon as you are ready, we will go over the answers together. Okay, at this point you should be ready to go over the answers for A and B. Letter A asked us to find the slope of a line that's parallel. So for line L, the equation was y equals negative 2x plus 3. This is in slope-intercept form, which means that the slope of the original equation was negative 2. Since parallel lines have the same slope, that means that a parallel line's slope would be negative 2. For part B, we were supposed to identify the slope of a line that's perpendicular. We will look for the opposite reciprocal. So we want a positive 1/2. That concludes the lesson on the introduction to slope. If you have any questions on any of the topics that we covered, please feel free to contact me and I will be more than happy to go over them with you. Thank you.